Hi everyone. So now it is the continuation of uniform flow, the module 2. So in that the first numerical, find the velocity of flow and the rate of flow of water through a rectangular channel is 6 meter wide and 3 meter deep when it's running full. The channel is having a bed slope of 1 in 2000. Take Chedge's constant C is equal to 55. So we can see the sketch of a rectangular channel which is having ABCD and the width is 6 meter and the depth is 3 meter. So here we can see the given data. Width is 6 meter, depth is 3 meter, bed slope I is equal to 1 in 2000 and C is equal to 55. Area of the flow, area will be calculated for a rectangular cross section is 6 into 3, that is B into D. 6 into 3 is 18 meters square. Then the wetted perimeter is nothing but where the water which touch the surfaces of the channel. So now we can see that the touching surfaces is between A to B, B to C and C to D, that is A plus B, B plus C, A plus A into B plus B, BC plus CD, that is AB is 3 meters, that is the depth, and BC is the width 6 meter and CD is the depth 3 meters. So 3 plus 6 plus 3. So AB plus BC plus CD, that is 12 meter. Then the hydraulic mean depth, that will be calculated by area by perimeter, that is M is equal to A by P, and the area is 18 meter square and the perimeter is 12 meter. Then hydraulic mean depth M is equal to 1.5 meters. Then we have to find out what is the velocity of flow. So to find out that, we know that from Chedge's equation, to find out the discharge in open channel flow, that is V is equal to C into square root of Mi. So C is given as 55 and M is calculated, that is 18 by 12 is 1.5 and I is given 1 in 2000. Then we'll get to know the velocity of flow is 1.5062 meter per second. But in this question we have to find out what is the rate of flow also. There are two unknowns. One is the velocity, other one is the rate of flow. Then we have the continuity equation. Q is equal to A into V. Area is 18 meters square and the velocity we have calculated as 1.5062. Then you'll get the discharges. Q is equal to A into V, 18 into 1.5062. That you'll get as 27.11 meter cube per second. Or you can say that will be as 27,110 liter per second LPS. So we know that 1 meter cube is 1000 liters. So you can do conversion in terms of LPS also. So but now they ask you to express in terms of SI units. But if they ask in specifically in terms of liter per second, then you can express that. So then move on to the second numerical. Find the slope of the bed of a rectangular channel of width 5 meter when the depth of water is 2 meter and the rate of flow is given as 20 meter cube per second. Assume Chedge's constant C is equal to 50. So we can see that in the previous numerical, they have given the width and depth of a rectangular channel as well as they have given what is the bed slope. And as well as we have to find out what is the velocity and discharge. But in this numerical, the slope of the bed of the channel is given. We have to find out the slope of the bed of the channel. But the thing is, they have given width and the depth as well as the rate of flow. It is nothing but the discharge. So it is opposite to the previous one. So now it is same, the rectangular channel with the width is 5 meter and the depth is 2 meter. So area is B into D, 5 into 2, 10 meter square, and the wetted perimeter is AB plus BC plus CD, that is 2 plus 5 plus 2, that is 9 meter. Then hydraulic mean depth is M is equal to A by P, that is 10 by 9 is 1.11 meters. And we have the equation to find out the discharge in an open channel flow is Q is equal to AC into square root of Mi. So here the Q is given, that is discharge is 20 is equal to A is 10 meters square into C is equal to 50 is given. Then square root of M is 1.11 into I is only the unknown. Then you'll get I will be as 1.441 into 10 power minus 3. Then you can express in terms of 1 in thousands. So you'll get now in terms of vertical by horizontal, that is I is equal to 1 by 694. That is the bed slope. In the third question, find the discharge through a trapezoidal channel. So previous two questions belongs to the rectangular channel. Now the third question is find the discharge through a trapezoidal channel of width 8 meter and the side slope is 1:3, 1 horizontal 3 vertical. The depth of flow of water is 2.4 meter and the value of Chedge's constant is 50. The slope of the bed of the channel is given as 1 in 4000, that is 1 by 4000. Then B is equal to 8 meter, D is equal to 2.4 and C is equal to 50, and as well as the bed slope is 1 in 4000. So we have to write the sketch. That is, we can see here in the sketch A, B, B, C, C, D. So A to B is the side slope, side channel, as well as it is equal to CD. And we have the base width is given as 8 meter. We have to find out what is the top width, that is A to D. So to find out that, the side slope is given. The side slope is 1 horizontal and 3 vertical, that is 1 by n. So now B to C is known as H to G, that is 8 meter. That is the width. Then we have to find out the top width. So to find out that, we should find out what is the n value. That is, we can see in this triangle, that is the triangle of AEB will be equal to the triangle of DCF. So if you want to find, we know that DF is the depth that is given, that is in terms of 3 for 1 meter depth. So we can write DF by CF will be as 3 by 1, or you can write CF is equal to 1 by 3 into DF. Or we know what is D to F, that is 2.4 meter width depth, then 1 by 3 into 2.4, then you'll get 0.80 meters will be the distance between C to F, or that will be equal to D to G. It is similarly in the triangle of AEB, that is the C to F will be the same distance between B to E, because the side slope is same. The same way I can write D to G will be the distance between A to H. Then the top width will be as 0.8 plus 8 plus 0.8, that is 9.6 meters. Then the top width you can calculate in other terms also, that is B plus 2n into D. So we have, that is 8 plus 2 into n is 1 by 3 into 2.4, that will get 9.6. So it is one and the same. You can calculate in other way also. That is one in terms of 0.8 plus 8 plus 0.8, or in terms of B plus 2nd. So you should remember the equation to find out the top width, it is B plus 2nd. Then area of the flow is, so we have the formula to find out the area of a trapezoidal cross section, that is A is equal to B plus nd into D. Then B is 8 meters plus n is 1 by 3 into 2.4 into 2.4. Then you'll get area of the flow is 21.12 meters square. Then the wetted perimeter. So to find out the wetted perimeter, we have the formula where the water which touches the surfaces, that is B plus 2D into square root of 1 plus n square. We can just substitute the values, 8 plus 2 into 2.4 into square root of 1 plus 1 by 3 whole square. Then you'll get the perimeter is 13.059 meters. Then we have to find out the hydraulic mean depth, because we have find out the area and the perimeter. Then the hydraulic mean depth is M is equal to A by P. That is, M is equal to A by P. A is 21.12, then P is 13.059. Then you will get hydraulic mean depth is 1.617 meters. Then we have to find out the end is discharge, that is Q is equal to AC into square root of MI. Then area is 21.12 meters square. C is given as 50 into square root of M is calculated 1.617 and I is given into 1.1 divided by 4000. Then discharge you'll get as 21.23 meter cube per second. Then go to the fourth one. Find the bed slope of the trapezoidal channel of bed width. So it is the trapezoidal channel. So in the previous case bed slope is given, but here in this we have to find out the bed slope of bed width is 6 meter and depth of flow is 3 meter, and the side slope of the channel is 3 horizontal is to 4 vertical. When the discharge through the channel is 30 meter cube per second, assume charges constant is 70. So it has same as previous one. So previous one we have find out the discharge, but the bed slope is given. But in this numerical they ask you to find out the bed slope, but the discharge, the width and the depth as well as the side slope is given. So we have to write the sketch, that is AB, BC, CD. Then the side slope is 4 by 4 vertical, 3 horizontal. Then we have to write N is 3 by 4, that is horizontal by vertical. So N is 0.75, that is 3 by 4. Then the top width will be calculated as B plus 2ND. So the width is 6 meter and N is 0.75, that is 3 by 4. So we can just substitute the values. D is 3, B and C is given. So we can just substitute the top width B plus 2ND as 6 plus 2 into 0.75 into 3. Then we'll get the top width will be as 10.50 meters. Then we have to find out the area of the flow. So to find out the area of a trapezoidal channel, we have the formula A is equal to B plus N D into D. Then we'll get that will be as 6 plus 0.75 into 3. Then area of flow is 24.75 meters square. Then the perimeter is P is equal to B plus 2D into square root of 1 plus N square. So just substitute the value 6 plus 2 into 3 into square root of 1 plus 0.75 whole square. So you'll get perimeter is 13.50 meters. Then we have find out the area perimeter. Then that will help you to find out the hydraulic mean depth. That is M is equal to A by P, that is 24.75 by 13.50 meter. Then you'll get the hydraulic mean depth will be as 1.833 meters. Then we have to find out the discharge is given. We have to find out the hydraulic bed slope. So to find out that, we have the equation for the discharge, that is Q is equal to AC into square root of MI. So Q as 30, area as 24.75. Then C is given 70 into square root of M is 1.833 into I. Then we'll get to know the I value will be as 1 in 6,113. So I will get to know the value for trapezoidal bed slope will be as 1 in 6,113. Then go to the fifth numerical. So it is for a V notch, or we can say trapezoidal triangle cross section. So for the triangle cross section, the fifth numerical, find the rate of flow of water through a V-shaped channel as shown in the figure. So the first four numericals, the first two is belongs to rectangle, and the third and fourth is belongs to trapezoidal, and the fifth one we are doing now with a V-shaped channel, or we can say triangle cross section. So find the rate of flow of water through a V-shaped channel as shown in the figure. Take the value of Chidge's constant as 55 and the slope of the bed as 1 in 2000. So sketch is given, the depth is given, as well as the bed slope is given. So C is equal to 55, I is 1 in 2000, then the angle between the section, that is where it has been changed. So we can see in the V-shaped channel, the triangle shape, we can see that again there will be of two right angle triangle. If we just draw a vertical line, that is B to D, so we can make that will be of two triangles, ABD, or that will be another one is BCD. So the depth is given as 4 meter. So from the figure, tan 30 degree will be equal to AD by BD. So we can consider the triangle of ABD. Then if you want to find out what is AD distance, because we know what is the depth, that is B to D, but we don't know what is the distance between the sides channel, that is A to B or B to C. So we have to find out AD, then that will help you to find out the other distance. So AD is equal to BD into tan 30, because we know tan theta is opposite by adjacent. Then if you want to find out what is opposite, then it is adjacent into tan theta, that is BD into tan 30 degree. So BD distance is known as 4 meter. So 4 into tan 30, then that will be getting as 2.309 meters. So remember it, what you are getting, 30 degrees is the angle between ABD triangle, as well as it is same as for BCD triangle. Then what you are getting, the distance for AD, that will be equal to CD. Then if you want to find out what is the total distance of A to C, then it is 2 times of AD, that is 2 into 2.309 meters. Then you'll get to know the AC distance will be as 4.618 meters. Then the area of a triangle will be as half into base into height. So height is given 4 meter and the width is we have calculated. So half into height into base is AC, height is BD, then 1 by 2. So 1 by 2 into 4.618 into 4. Then you'll get the area is 9.236 meters square. Then in the triangle of ABD, we can see that if you want to find out the side length AB, or if you are taking the another triangle BCD, then if you want to find out BC, so what you are getting A to B, that will be equal to B to C. So we'll consider the triangle of ABD, then we'll find out what is AB, that will be equal to BC. Then AB is equal to square root of AD square plus BD square. So AD as 2.309, then BD as 4. Then substitute the value, square root of 2.309 square plus 4 square. Then you'll get to know the AB length will be as 4.618 meters. Then that will be equal to BC. Then wetted perimeter. So we have calculated AB as well as BC. That will be help you to find out the perimeters, because the water touch the surfaces is between A to B and B to C. So then perimeter is AB plus BC. that is 2 into 4.618 meters, or you can say 4.618 plus 4.618, that you will get perimeter will be as 9.237 meters. And then hydraulic mean depth is A by P, M is equal to A by P. Area is calculated and perimeter is calculated. So area is 9.236 meters square and perimeter is 9.237. Then you will get hydraulic mean depth is 1.0 meters. Then we have calculated what is area, H's constant is given, M we have calculated, I is given. Then we can substitute the discharge equation, Q is equal to AC into square root of MI, that is area is 9.236 meters square into 55 into square root of 1 in 2000. Then you'll get the discharge will be as 11.358 meter cube per second. So these are all the numericals which is belongs to the uniform flow in the open channels. So all of you can keep the notes. I'll just forward the notes, as well as you can keep the video. When you're going through the video, all of you just keep the notes and just practice all the numericals what we have discussed in this session. Thank you.